Hi, this is the next video for Year 1 Further Maths Pure. We're gonna, excuse me, we're still on the vectors, looking at exercise 9C. Now, example 10, example 10 is showing you how angles on a straight line add up to 180, so I'm not going to bother with example 10. But what is important is this dot product. It's called the dot product or the scalar product. And it's an operator that we can do with two vectors. So the sign is a dot. It's defined as modulus of A multiplied by modulus of B multiplied by cos theta. And if I have the two vectors going away from a point, and that's important, they both need to be going away from a point, then theta is the angle in between. You can actually see, if you look back at example 10 has a vector going away from a point, a vector going towards a point. So the theta here would actually be if I moved the vector going towards a point so that it was going away from the point, theta would actually be that angle there. But you know, if I need an acute angle, clearly I can see that I'm going to get an acute angle here, and if I wanted the obtuse angle between two vectors, well, I could just take it away from 180 anyway. So the dot product, mod A mod B cos theta. Now obviously, if two vectors are perpendicular, then theta is 90 degrees and cos 90 degrees is 0. So A dot B equals 0 if A is perpendicular to B. And of course, if they're parallel, then the angle between them is 0. And cos 0 is 1. So A dot B, if cos 0 is 1, then A dot B equals mod A mod B if A is parallel to B. So dot product being 0 means they're perpendicular. Dot product being mod A mod B means that they are parallel. This is quite a useful result, it being perpendicular, and we're going to use that a lot in later exercises. I'll just have a swig of my tea. Right. Example 11. Well, find the values of I dot j. Well, I know that I is horizontal, length of 1. J is vertical, length of 1. I dot j is mod I mod j cos 90, which of course is 1 times 1 times 0. I mean, I could have just gone straight to 0 because I know that if two vectors are perpendicular, then their dot product is 0. K dot k, well, not surprisingly, k dot k, well, it's mod k cos theta. Well, since k is, itself, the angle between a vector and itself is 0, 1 times 1 times cos 0, which is 1. Let's just look at this. The next one is a little bit more complex. 4j dot k, 4j dot k plus 3i dotted with 3i. Well, j and k are perpendicular, So 4j dotted with k is also perpendicular. 3i, well, I is parallel to itself, so 3i dot 3i is mod A mod B, 3 times 3 times cos 0, which of course is just 9. So the dot product, the scalar, the reason it's called a scalar product is because, oh, I had a penguin. The reason it's called a scalar product is because the answer I get is a scalar. It's a number. Yeah, dot product, scalar product, same thing. Example 12, I'm not going to show, you can read yourself, but it does give us an alternative way of expressing the dot product. So A dot B is A1B1 plus A2B2 plus A3B3. Again, you can read yourself, you can have a look at example 12 and convince yourself that this is true. You don't need to be able to prove it's true, but you do need to know that it's true. So we have these two alternative ways of expressing the dot product or calculating the dot product. And that's useful. Well, we'll see why. We'll see why from example 13. So A equals 8 minus 5 minus 4. B is 5, 4 minus 1. Now A dot B, well, we can either use Pythagoras, find the modulus, use Pythagoras, find the modulus. In fact, we can't find the dot product using the initial definition because we don't know theta. We've got to find theta. But I know A dot B, 8 times 5 plus 4 times minus 5 plus minus 4 times minus 1. Just multiply corresponding elements. 24. Let's turn the page. So let's write out the vectors again. A is 8 minus 5 minus 4. B is 5, 4 minus 1. And I know that A dot B is 24. Well, let's use the original definition. Mod A, mod B, cos theta. Well, I know that that equals 24. Now, mod A is, I'll just use Pythagoras on A. 8 squared plus 5 squared plus 4 squared, root 105. Mod B, square root of 5 squared plus 4 squared plus 1 squared, root 42. So I can write root 105 times by root 42 times by cos theta equals 24. So cos theta equals 24 over root 105 root 42. So theta is 68.8 degrees to 1 dp. Now, it didn't ask for the acute angle or the obtuse angle, it just said, tell me the angle. There you go, done. Example 14, same. Let's have a go at it. A is minus 1, 1, 3. B is 7, minus 2, 2. Find the angle. So A dot B is minus 1 times 7, add 1 times minus 2, add 3 times 2, minus 3. Mod A is the square root of 1 plus 1 plus 9. Mod b is the square root of 49 plus 4 plus 4. So mod a, mod b, cos theta equals minus 3. So cos theta is minus 3 over root 11 root 57. Now the calculator's here. I'm in degrees. I'm not in degrees. Let's turn it into degrees. That's it. Minus 3 over root 11 root 57. I was just checking that the calculator actually does give me a positive answer. Of course, if it gave me a negative answer, then I'd have to use my cos or sine graph to work out the positive angle. 96.9 degrees. Okay, obtuse angle, fair enough. Okay, example 15. Given that they're perpendicular, find the value of lambda. So perpendicular, remember, means they have a dot product of 0. A is 2 minus 6, 1. B is 5, 2, lambda. A dot B is 10 minus 12 plus lambda. Perpendicular means that A dot B equals 0, so that minus 2 plus lambda equals 0, so lambda equals 2. Done. And yeah, example number 16. Okay, example 16. A is minus 2, 5, minus 4. B is 4, minus 8, 5. Find a vector which is perpendicular to both of them. So let's say I want to find this vector x, y, z, where a dot r equals b dot r equals 0. So a dot r is minus 2x 5y, excuse me, plus 5y minus 4z. B dot r equals 4x minus 8y plus 5z. They're both equal to 0, so I'll set them both equal to 0. Minus 2x plus 5y minus 4z equals 0, and 4x minus 8y plus 5z equals 0. Now I just need three values, x, y and z, that satisfy both these equations. I've only got two equations, so I can just pick a value for x, y and z. It seems sensible to pick a non-zero value for x, y and z. I haven't thought through fully whether I actually need to pick a non-zero value. I'll have a think about it, but let's say x equals 1. I get minus 2 plus 5y minus 4z equals 0. So let's write that in the form that I'm used to with my simultaneous equations. There's equation number 1. 4 minus 8y plus 5z equals 0, minus 8y plus 5z equals minus 4. Equation number 2. Let's solve these simultaneously. Where is my calculator? I keep on losing it. There it is. Uh, 5 minus 4, 2 minus 8, 5 minus 4. So y is 6/7, z is 4/7. So r is 1, 6/7, 4/7. You might like to multiply through by 7 just to have whole numbers. Doesn't matter if you don't know. So there's lots of vectors, possible vectors I could have that will be perpendicular to A and B. They'd all be multiples of the same thing. Example 17, you may have noticed my edit. This is me second go at it. We've got position A, 2, -1, 1. Position B, 5, 1, 7. Position C, 6, -3, 1. Now we can easily work out vectors for A, B and AC, and since I've drawn them both going away from the same point, I could also work out the angle, and so I can work out the area of the triangle because I'm going to know the length of these sides. So, part A, from A to B, from 2 to 5, 3, -1 to 1 is 2, 1 to 7, 6. From A to C, 2 to 6, 4, -1 to -3, -2, and 1 to 1, 0. So AB dot AC is 3 times 4, 12, 2 times -2, -4, 6 times 0. So AB dot AC equals 8. Mod AB dot mod AC dot cos theta equals 8. So I'm going to use the other definitions of the dot product. I know mod A, I don't actually know mod AB yet, do I? Mod AB is the square root of 9 plus 4 plus 36. That's 7. Mod AC is the square root of 16 plus 4. 20, 20 is 4 times 5, so 2 root 5. So cos theta equals 8 over 7 times 2 root 5, 14 root 5. Now remember, the area of a triangle is half AB sine C. So I need the sine of the angle in between rather than the cos of the angle in between, but that's okay because we know that cos squared theta plus sine squared theta is equal to 1. Then sine theta is equal to the square root of 1 minus cos squared theta. And I know cos theta is 8 times 14 root 5, so I'll square it, take it away from 1, square root it. So sine theta is the square root of 229 over 245. Now it needs to be positive because remember I'm trying to find an area, so I'm glad that it's positive, because if it were negative it would still give me a negative area and that would have a certain interpretation, but we'll not go there just for this question. Right, so the area of the triangle is a half mod AB times mod BC times by the square root of 229 over 245, which is 15.13. Don't know if it's centimetres or what, it doesn't really matter at this stage. Units. Now they did that slightly differently in the book. What they did, given cos theta, was they found theta, then they found sine theta. Obviously I prefer this because that's how I did it. To me this is better because we get an exact value, because if you inverse cos you get a value for theta which you then have to round because this won't give you an exact value. This of course is an exact value, but you know we ended up with the same answer to do dp anyway. Okay, give 9c a go. See you later.